Hi friends, now we will start discussion on the topic energy conservations. So far we have discussed on the production of energy from fossil fuels and from different renewable energy resources, and we have discussed how the energy can be produced in more cleaner way from the fossil fuels also. After taking sufficient efforts to develop newer technology, newer cleaner technology, we are able to reduce the emissions and to achieve sustainability goal, but there are still some scope that is not fully technical, but that is based on the practice. So, that is called energy conservations. So, here our target is to know about the practices or the ways which we can implement to reduce the need of electricity to perform the specific work, that is to prevent the loss of electricity on other way also. So, in this class we will discuss on energy conservation for optimization of energy usage and practice for energy conservation. Now, we will see the energy conservation for efficient use of energy. There are some energy efficiency and GDP. If a country has more GDP, this does not mean that it is also energy efficient country, then energy efficiency may be less also, as we have discussed in our previous classes. So, here how we can increase that efficiency, that is the point of discussion, and if we can develop some practice, we can improve that energy efficiency. And Government of India has also taken some measures to achieve this target, the energy efficiency, to increase the energy efficiency, and the energy conservation bill in 2001 the government has passed for better utilization of energy and conservation of the same, that is energy. And Bureau of Energy Efficiency has been established, and this body keeps watch on energy consumption patterns and develops norm and appliances. And they have developed the star ratings, that is BEE has also initiated star rating system for electrical appliances and CFLs, geysers, refrigerators, etc. And energy conservation can be achieved through increased efficient energy use in conjunction with decreased energy consumption and or reduced consumption from conventional energy sources. So, this any individual or any organization can develop the practices, and they can choose to conserve energy, to reduce energy costs and promote economic security. So, this energy consumption refers to efforts made to reduce energy consumption basically, and we will see some energy conservation areas where there is a good scope for energy conservation. So, energy conservation at households, at each household level we can develop some practice so that the energy wastage will be reduced and utilization will be improved. And energy conservation in industry and other places also, there is lot of scopes, and energy conservation at community level, then also we have scope here. Energy conservation in transportation sector, energy conservation in agricultural farm. So, these are some area where there is a good scope for the conservation of energy, and we will discuss that part. So, energy conservation at household level. So, at household level, so energy conservation in major appliances for domestic use are say refrigerator. So, we can conserve energy here, refrigerator. We can conserve energy at oven or micro oven. We can conserve energy in ironing and conserve in cooking, energy conserving in washing machine, etc. For example, if we in case of cooking, if we use less gas flow rate, then it takes some more time for cooking, but the loss of heat is reduced significantly. Similarly, for iron, we need not to keep the iron on for a longer period. If we use auto control mode, then it is better, it will be conserving electricity. And similar for refrigerator, we may maintain the temperature which is required for us, we may not go for sub temperature. So, there are some specific applications when we need, we will go to that extent, otherwise we will be using in normal range. So, that way also we can do. And energy conservation during lighting. So, during lighting we can also follow some procedure, so that our eye will not be affected, we will be getting sufficient luminescence from these, and at the same time we will be able to reduce the wastage or unnecessary use of electricity. Energy conservation during cooling, the cooling system also, there are some natural cooling systems are also that can be used, say water spray, that also can gives a good cooling, one example of that energy conservation of that. And energy efficient building constructions, the building can be constructed in such a way, so that passive building constructions, as we have discussed in the previous class also, that helps to take heat from the outside into the room in winter days, and in summer days the reverse, it prevents the passage of heat from outside to inside. And energy conservation in industry, that is, so to conserve energy in the industry, the one practice is very important and it is prevailed, that is energy auditing and process modifications. If we have some process which is using more energy, then we can replace that one, or there are a number of techniques, that is pinch analysis, that is optimization of the energy used in the or heat loss, to reduce the heat loss in a unit or in the process industry, so those are also used. So, process modification and improved measuring instruments, energy loss reductions by pinch technology that we are talking about, and that can also help the process modifications, and light load reduction. So, this is some process through which the industry can achieve more energy conservation, and energy conservation at community levels and housing complexes also. So, there is some housing complexes, if we can develop some technique that all lights will be stopped when it is not necessary. So, some timers may be used, when the people will go on that way, the light will be on, and when there will be no one, the light will be off automatically. That way also the energy conservation can be achieved. And training program about energy efficient repairs should be organized, and only single elevator lift should be operated during non peak hours. When there are non peak hours, then we do not use multiple lifts, and water pump should be switched off during non peak utility hours, and installation of photoelectric controls or timers should be used, that we are discussing. Then energy conservation in transportation sector. So, in transportation sector also, if we can develop some practices, then also we will be able to control the loss of the energy and conserved energy. Like say car speed should be maintained as far as possible 50 to 60 km per hour. So, engine are designed in such a way, this time the well oil requirement becomes less, fuel requirement becomes less or optimum, and we should avoid frequent starts and stops to reduce fuel consumption. We should apply brakes gradually as far as possible. Fuel economy, that maximizing behavior, fuel economy maximizing behavior, moderate driving and driving at lower speeds, and turning off a vehicle's engine at stops rather than idling and using cruise control. So, these are some practices which can adopt to conserve energy in this sector. And energy efficient building construction, that is very good insulation of walls, roofs and basement, and then windows with high quality double or triple glazing. So, that also helps the energy conservation. Airtight construction, avoid cooling demand, that is sun setting in summer and natural cooling sources. So, that way we can do it. And during lighting, when we will use the lighting systems in the residences, we can think about the requirement of energy and then how much energy we are actually putting. So, interior lighting power allowance, that is called interior lighting power allowance by the building area method is determined by some procedure. So, there are two methods to determine how much light is required in the building, that is building area method and space by space method. So, we will be discussing the building area method. So, what is the meaning of this method? That we have to determine allowed lighting power density LPD, lighting power density in table here. So, lighting power density. So, if we have different parts of the residence, that is automotive facility, then we have convention center, we have dining, we have bar, lounge or say cafeteria, dining in a family dining, dormitory, gymnasium, healthcare and clinic and hospital and hotel, library, manufacturing facility, motel, motion picture theatre and multifamily residential, museum, office, parking garage and performing arts theatre and police, fire station, post office, religious building, retail or mall or school, university, sports arena, transportations, warehouse and workshop. In these different areas, this is the LPD. So, there is the lighting power density. So, these are the lighting power density we need. We do not need the lighting power density of 11.8 watt per meter square in case of automotive facility, which is required for museum. So, more energy is required in case of, more light is required in case of museum, more is required in case of arts and theatre. So, less is required in case of warehouse, less is required in case of automotive facilities, but we many time we cannot identify these areas and the requirement and we use more energy. So, if we have some idea on this, the requirement of energy for different areas, and we accordingly we can use different area, different power of the bulbs, then we can conserve some amount of energy. So, this is the concept of these energy conservations in lighting area, and how can we calculate the total energy required, or that can be done by this formula ILPA, that is interior lighting power allowance. So, that is equal to sum of GLFA into LPD. What is LPD? That is your lighting power density, and so GLFA, that is what is the total area we are having, different types of area we are having. So, that will be multiplied by LPD of each, that is gross lighted floor area GLFA. So, different types of area we have. So, somewhere we may have 2 kitchens, we may have 2 garage. So, all those cases we have to multiply this with the number. So, area, so we are have a gross lighted floor area into LPD, that is the lighting power density. So, type of building or area, type of area and the area of that type into LPD of that type, then we will sum up all those things, all the areas, then that will give us ILPA, that is the interior lighting power allowance. So, that way it is calculated. Now, energy conservation in industry through motors. When we use the motors in industry, then we have to be careful for the operation of this, because there are in some cases what happens, the power which is coming to the motor, that is not completely converted to the work. So, there are some power factor. So, that power factor is there, that is equal to true power by apparent power. So, true power W by VA, that is mentioned here. So, W by VA, that is equal to true power by apparent power. So, power factor is an expression of energy efficiency and is the ratio of the true power in a circuit to the apparent power delivered to the circuit. So, this is the definition of the power factor. So, motor has that power factor also. So, in case of more the power factor, will we get more true power. So, how much power the motor is getting and how much it is converting to the usable form, that is our power factor. So, here we have some correlation, true power and this is apparent power. So, watt and this is VA. So, this is the relationship and this is reactive power. So, how much true power, reactive power, apparent power. So, these three types of powers we have and these are the related like this. So, say we need to get certain amount of work done by the motor, that is what amount of work is being done, that is your true one, that actually I have done it, that you energy used for that application, and what amount is coming as input to the motor, that is our apparent power. So, this ratio is power factor. Now, poor power factor can result in heat damage to insulation and other circuit components, reductions in the amount of available useful power and require an increase in conductor and equipment sizes. And demand, which is also known as the apparent power, kVA, is the measure of the amount of power used to run machinery and equipment during a certain period of time. So, if I have increased my demand, but the supplier is not able to meet that requirement. So, the supplier may impose some restriction on it and can impose some tax on it, means add some charges, demand some charges to the bills of large customers to offset differences between supply and demand. So, that way that is practiced. Okay. So, many utilities added demand charge, okay, when the demand is greater than the power is available. So, now we will see one example. So, after this which we understand that the power factor, if we can increase, then our energy loss will be less and energy conservation will be more, we will be able to save more energy or get the work done with using lesser amount of energy. So, that is the case. That is why the motor which is used, that is called energy efficient motor, which is having high power factor. We will see some numerical problems. Say a 60 horsepower standard AC motor is operated for 85% time in a year at 75% load with efficiency and power factor as 82% and 0.8 respectively. Standard AC motor is replaced by an energy efficient motor of same capacity, that is at 75% load. The efficiency and power factor of energy efficient motor are 87% and 0.83 respectively. Cost of standard AC motor and energy efficient motor are 1,10,000 and 1,20,000 respectively. Taking energy consumption charge as rupees 3.10 per unit and kVA demand charge as rupees 175 per kVA per month, calculate the following if the motor operates 20 hours a day and 300 days in a year. So, we have to calculate annual saving and payback period. So, this is the problem statement. If we want to do it, then what we have to calculate? We have to calculate the energy requirement in case of standard motor and energy requirement in case of efficient motor, energy efficient motor. So, in this case energy efficient motor will be using less energy and that amount of less energy is our saving, and to get we will multiply this by the price, unit price of the electricity, then that is the total monetary saving, and then annual saving we can calculate, and payback period we can get that this is the time at which the total investment will be returned in terms of expenditure of money, and then there may be two cases, one is total amount which you are investing or another is the gap between two standard and efficient motor. So, now the problem statement 60 HP it is given. So, 1 horsepower equal to 750 watt we know, if we can assume, then 60 horsepower is 16.75 kilowatt. So, this is the rating of standard AC motor, and then input power to the motor, that will be 45, it is with 75% load. So, 0.75 again 45 into 0.75 and with 82% efficiency. So, 0.82, that is 41.16 kilowatt the input power to the motor. Then what will be the output power of the motor? It has 80% efficiency. What is the power of power the motor is taking, that this motor is taking how many power. So, it will be giving out input, this output, that is equal to 0.8. So, this will be 0.8 of input. So, that is so what is the KVA demand? So, KVA demand is equal to power factor is equal to given here 0.8. So, that power factor is 41.16 divided by 0.8 equal to 51.48. So, if it gets 51.45, then it will give us 41.16. Then what is the KVA charges? This KVA demand into charge is given here 175 rupees per KVA per month, and per year we have 12 months. So, it will be for 51.45 into 175 into 12, that is equal to 1,08,045 rupees. And energy charges, so how much energy it is using? 41.16, we are using this energy. So, this into 3.1 per unit, and we have 20 hours a day, and we have 300 days per annum. So, this is the total amount for electricity charge. So, demand plus energy charge or cost per year, that is equal to this amount plus this amount. So, 7,65,576 plus 1,08,845. If we add 8,73,621, we are getting this much of total expenditure for standard motor. If we use the energy efficient motor, then the rating of energy efficient AC motor is again it is also 60 HP, and so 60 HP equivalent to 60 into 0.75, that is 45 kilowatt, and its efficiency is higher, that is 87%. So, input power to the motor will be this 45 into 0.75, that is actually it is using, but as it is 87% efficient. So, it has to be divided by 0.87. So, this is the 38.79 kilowatt, this is the input power to the motor. Then what will be the KVA demand? Then we have to know the power factor. Power factor in this case is equal to 0.83. So, we will divide it by 0.83. So, 38.79 divided by 0.83. So, it is 46.73 KVA. So, this is our demand. So, now KVA charges how much? Again this into 175 into 12. So, that is equal to 98,133 rupees. And what will be the energy charge in this case? We need energy is equal to 38.79 kilowatt. So, 38.79 kilowatt into 3.10 into 20 hour per day into 300 days per year. So, it is coming 7,21,494 rupees per year. So, total charge will be this plus this. So, we are getting energy plus demand charge. So, it is coming demand charge, that is coming 8,19,627 rupees. So, here we are getting this much in the standard. If we use the standard motor, our charge is 8,73,621, and here 8,19,627. So, the difference is 53,994 rupees. So, this is our saving actually. So, payback period, if I want to get the whole money back, to get the, that is 1,20,000 for the energy efficient motor, then we have to divide this divided by 53,994. So, the 2.3 years. But if I want to get the difference, that is 1,20,000 minus 1 lakh. So, 20,000 divided by 53.994. So, 0.37 year, that is equal to 4.5 months. So, that way we can calculate the requirement of the demand, that way we can calculate the demand in KVA, that is apparent energy, and we can calculate the energy charge and overall expenditure for this motor application. Now, here we see the energy efficiency how can be improved in the pumping set. So, this is your standard pumping set, and here energy efficient pumping set. So, here we have added one new device. So, what was STD here standard input power, we have 100 units, the same amount of work we can get here by using 43 unit, output is same, and this is made by the changes in the units which are used for the operation of this motor. So, important is a variable speed drive if it is used. So, it is 99% efficient. So, here we have conventional pumping system efficiency is 31%. So, here it is 99% if it is used, then this also energy efficient tube motor, that is also giving us very high efficiency. So, that way these each parts which are having less efficiency here, but by the use of modified parts we are able to get more efficiency. As a whole, we can get the same amount of work by using less amount of energy with respect to standard motor. So, to be considered energy efficient, a motor's performance must equal or exceed the nominal full load efficiency values provided by the National Electrical Manufacturers Association. They have given a list, this is specific full load nominal efficiency values are provided for each horsepower, enclosure type and speed combination. So, by the comparing that we can get whether it is energy efficient or not. Improved design, materials and manufacturing techniques enable energy efficient motors to accomplish more work per unit of electricity consumed, that we have discussed. Now, some energy conservation devices we will see. One is your CFL. So, as you know that CFL uses less energy to give same luminescence to the conventional bulb, and pressurized steam cooker and solar cooker another example, and natural water cooler is a safe drinking water device which works on the principle of cooling by evaporation. No external source of energy such as electricity or ice is required. This is cooler, this is your solar cooker and these are CFL. So, it has been shown that a tube light of 40 watt with a choke of 20 watt, that is total 60 watt, the watt luminescence they can give, the same amount of luminosity can be given by a CFLs of 18 watt. So, there is a 60 minus 18 42 watt or 70% saving in the electricity. Now, here are some calculations. The annual energy saving when 340 tube lights originally deployed are replaced with 18 watt CFL lamps. So, 14 watt tube lights with 20 watt choke and 18 watt compact fluorescent lamp CFL that we have just discussed. So, what will be the saving? Just is with tube light 60, 40 plus 20, 16 to 12 into 365, that is 263 kilowatt hour, and CFL is 18 into 12 into 365, and 12 is the average day hour used per day. So, that is equal to 79 kilowatt hour. So, the saving is 263 to 79 184 kilowatt hour. So, the cost is say 3.40 rupees per unit. So, multiply this into this, so rupees 625.60 per unit. So, total unit we are using here 625 into 16 to 340, that is equal to this one. This is our annual saving. This 340 tube we have. So, that is why this multiplied by 340. So, we are getting this much of annual saving by this implementation of this project. Now, there are some tips for energy conservations in agricultural pump. So, selection of proper capacity of pumps according to the irrigation requirement, then matching of pump set with source of water canal or well, and matching of motor with appropriate size pump, and proper installation of the pump system shaft alignment, coupling between motor and pump, and use of efficient transmission system, maintain of right tension and alignment of transmission belts, and use of low friction rigid PVC pipes and foot valves, and avoiding necessary bends and throttle valves, use of bends in place of elbows. The suction depth of 6 meter is recommended as optimum for centrifugal pumps. The delivery line should be kept at minimum required height according to requirement, and periodically check pump system and carrying out corrective measures like say lubrication, alignment and replacement of worn out pairs can help to improve the conservation of energy in agricultural pump, because all of these are basically dedicated to reduce the loss of energy. So, these are some tips or some discussion on the energy conservation after this in this class. Thank you very much for your patience.